about aromaticity and also the benzene structure of benzene. So the important topic. You'll be getting questions from aromaticity. So mostly in JE and in NEET exams. So you'll get questions from this aromatic property. So first of all, before going to discuss about aromaticity and aromatic compounds, let us discuss what are arenes. So what are arenes? Arenes are the hydrocarbons. So here the definition, what definition is, the definition is about arenes. So arenes are hydrocarbons which contain benzene ring is a main. Means aromatic compounds or hydrocarbons having at least one benzene ring are said to be arenes. And other fundamental property of the arenes is that having the pleasant odor, that means aroma. So aroma, so pleasant smell the aromatic compounds have, and so these are the class of compounds are said to be aromatic compounds, and these aromatic compounds so containing the benzene ring, so then they are said to be what we call means benzenoid compounds. And in the aromatic compounds not having the benzene ring, there are said to be non-benzenoid compounds, we say. The major characteristic property of the aromatic compounds, possession of unsaturated ring. Unsaturated means having that double bond, alternate double bond, what we call conjugated double bond, we say. So that means simply I would like to say aromatic compounds classified into two types. So one is benzenoid compounds having the benzene ring and unsaturated ring they consisting of. The second type is said to be non-benzenoid compounds we call. So examples. So we can give examples benzene, aniline and naphthalene. So anthracene comes under so what we call means benzenoid compounds having the benzene ring as a unit, main unit we say. These are also otherwise called polynuclear aromatic compounds also we say. And so now non-benzenoid compounds we can write azulene is the non-benzenoid compound, tropolone or tropone. This is a tropone is the non-benzenoid compound. We can give example tropone or non-benzenoid compounds not having the benzene ring. Now, so if we go for the classification, here we should talk about classification of molecules based on aromatic nature, aroma. So here classification of these hydrocarbon aromatic molecules classified into so aromaticity, aromatic molecules, anti-aromatic molecules, non-aromatic molecules, and homo-aromatic. So we'll go means if we talk about so arene compounds, then we must discuss about aromatic nature, because aromaticity is the fundamental characteristics of the arene compounds. So then in this lesson I'm giving more importance for the discussion of what means aromatic characters. So what is the major requirement, major condition for the aromaticity of hydrocarbons? What property is required? So here I have mentioned here. So number one is the molecule should have planarity structure. So planarity structure means how the molecule gain the planarity structure means the molecule can get the planarity based on so hybridization of the carbon atoms. So particularly sp2 hybridization. If the carbon atoms present in the cyclic ring undergoes sp2 hybridization, definitely the molecule get the planarity. That means The condition is that aromatic nature is that should have the cyclic character and a planar structure. The carbon atoms present in the ring, cyclic ring, should undergo sp2 hybridization. sp2 hybridization. So that means the planarity is the major criteria due to hybridization in the carbon atom. That is what we call means sp2 carbon due to the presence of sp2 carbon planarity structure. The second fundamental characteristic of this aromaticity is that complete delocalization of pi electrons within the ring. In the cyclic ring structure, there are pi electrons are present. So due to the delocalization, what is the meaning of delocalization? Delocalization means movement of pi electrons between the carbon atoms, or they are in conjugation, they are in resonance with the resonance, we can say pi bond electrons movement, that is called delocalization within the ring. The third important property for the aromatic nature is that they should follow the rule 4n plus 2 rule. 4n plus 2 pi electrons rule. So if the ring follows 4n plus 2 pi electrons rule where n is equal to 0, then 2 pi electrons we can get. The n is equal to 0 means 2 pi electrons, and when n is equal to 1 means and what we can get, n is equal to 1 means 4 into 1 plus 2, so 6 electrons, 6 pi electrons rule, 6 pi electrons rule the compound exhibit, and n is equal to 3, 12 plus 4, 14 if you take this, n is equal to 2 into 4 into 2 plus 10, 10 electrons, pi electrons rule, the molecule follows pi electrons, so 10 pi electrons, and if that n value is equal to 3, so 4 into 3, 12 plus 2, 14 electrons. That means 2 comma 6 comma 10 comma 14, 14 if the ring possesses, or if the aromatic compound possesses this 2 pi, 6 pi, 10 pi, 14 pi electrons, so then and such molecules purely exhibit aromatic character according to Huckle Rule. We say this is called Huckle Rule 4n plus 2 pi electrons rule, we can say. That means aromaticity is a property. That property depends on aromatic property depends. See, the arenes are the compounds having more stable nature. Though they containing double bond because of these reasons, we can say cyclic character, planarity character, delocalization of electrons, and following that Huckle rule 2 pi, 6 pi, 10 pi electrons. So that is aromatic nature we call, and sometimes means do all the aromatic compounds, all the compounds hydrocarbons, do all the hydrocarbons exhibit this aromaticity means no, and some molecules having non-aromatic nature, some having that homoaromatic nature, some will have that anti-aromatic nature, we say. So here, what is non-aromatic means? So non-aromatic property is, what non-aromatic nature means, the molecule may be cyclic or non-cyclic, and not following that planarity, so no delocalization of electrons, and not following this, what is that Huckle rule, not following means that compound is non-aromatic, we say. So non-aromatic compound. So look at this A compound is given. You can look at this A compound. This is non-aromatic. So and this molecule also cyclic. This molecule also cyclic. You can see but number of double bond 1, 2, 3, 4 are present. Alternate. But alternate, but not following that Huckle rule. So 4n plus 2 number of electrons, 8 electrons are present, pi electron system, 8 pi electron system. This is non-aromatic, we say. And after this, after having studied about this one, There is another one is aromaticity property also there. So what is mean by anti-aromaticity? So anti-aromaticity also, so molecule having anti-aromatic molecules also following what they can follow this anti-aromatic also planarity, cyclic molecules, anti-aromatic. You can look at this structure here. So look at this structure here. So there is sp2 carbon is present, sp2 carbon is present, and this negative ion, anion. So here there is a negative charge is present. In this anti-aromatic, just a minute.